did the incline plane video, or pardon me, the incline plane problem. On the quiz, I think I switched A and B. So on the quiz, I believe A is the top angle and B is the bottom angle. When I was working it out here on the board, I just started with A and then B. So in this example, my bottom angle is 30 degrees, my top angle is 15. I think on your quiz, the lower angle is smaller. And in this example, I'm using 10 meters per second for my initial velocity. However, I'm not going to actually plug those numbers in until I've solved the entire formula as one big honking formula. So here are the things that I know. With my V naught here, I can calculate my my distance or my velocity in x. My velocity in x is V naught times the cosine of the sum of these angles A and B. And Vy is V naught times the sine of the sum of these angles A and B. I also know my distance that it's going to travel in x. In this distance, since there's no effect of gravity or acceleration there, I just use my distance formula, which is distance is equal to velocity times time. So here's my velocity, V naught cosine of the sum of the angles times time. So V naught cosine A plus B times time is my horizontal distance in x. My vertical distance in x is given by, or in y, is given by my formula for vertical distance with the effect of gravity. So I have my initial velocity, V naught sine A plus B times t, so that's my initial velocity times t, plus 1/2 gravity times squared. So that's my my distance in y. Now that I know distance in x and distance in y from a formula basis, is there a new relationship between the two? And there is. They told me if I'm hitting up here, way back in trig or pre-cal or even geometry maybe, that this distance being opposite of this angle and this being adjacent to this angle, my distance in y divided by my distance in x is the tangent of this angle. So the tangent of angle A is equal to distance y divided by distance x. So knowing that tangent of angle A is distance y, which is this number up here, V naught sine A plus B times t plus 1/2 gt squared, divided by the dx, which is V naught cosine A plus B times t. I've got t squared and t, so I can cancel a bunch of t's. It leaves me with just one there. And then I can multiply both sides by this denominator to get rid of the denominator and move it over to the other side. And I end up with V naught cosine A plus B tangent A is equal to V naught sine A plus B plus 1/2 gt. Now, I can subtract this from both sides, which I did, and combined the V naught in the front. And then I multiply both sides by 2 to get rid of the 1/2. And I divided both sides by g to get rid of the g on this side. And I end up with t is equal to all of this. So that's how I solve for the time, which is what you were supposed to do on the quiz. We can also solve for other things. If I plug in my initial conditions where A is 30 degrees, B is 15 degrees, and V naught is 10 meters per second, some of these, like A plus B is always 45 degrees. If I plug all that in and plug in 10 meters per second as well, I end up with T being 0.61 seconds. Now, on here I use 9.8 meters per second squared for gravity. You can use 10 on the quiz. The quiz answers are based on 10 meters per second. But I use 9.8 on this. If I then plug my 0.61 seconds back into dx, the equation for dx, I end up with dx being 4.31 meters. And if I plug the 0.61 seconds into my equation for dy as a function of time, I end up with 2.49 meters. So I not only know when it hit, which was 0.61 seconds later, I know that its range here was 4.31 meters in x, 2.49 in y. And if I wanted to see how far along that hill was, what could I do? I could use Pythagorean theorem, right? 2.49 squared plus 4.31 squared is equal to the range squared.